Welcome back to Rubber Duck Engineering. Hello, Adam.
Hi, Eric. What are we talking about this week?
Tonight we are going to talk about. I think I put the show title as typed handles. We're going to talk about our garbage collector and making the APIs easier to use, including adding a typed handle so that the Rust type system has any prayer of helping us whatsoever.
I feel like this is a common thing when you write a library, that you live inside the library for a while and you finally get it working. And then you first try to use it and you're like, oh boy, this thing is totally unusable from the outside.
Yep.
Because you actually tried to integrate this into the Wren VM, right?
Yeah, so we actually haven't worked on the GC in probably about 2 weeks because we went off on our little excursion with Flutter and we had Bob on the show. But before both of those happened, I actually spent a while on weekend trying to integrate the GC into the Wren library and wrote down a bunch of notes, some of which we'll use tonight in order to sort of understand what we're building towards. But I think we need to move towards a set of examples of using the GC well, because our existing examples are kind of clunky, and if I needed to apply that to 10,000 lines of code or whatever the heck the interpreter is these days, I don't think we'd be in for a fun time.
So you think we should look at some example uses and try to write some fantasy code for we wish we could use the library like this, and then try to make that possible? Is that a sensible approach?
Yeah, I think that's a fine approach. I also gave, when we pull up the code machine, I gave some examples. I copied them into sort of our README in sort of a little to-do list of just examples that I pulled out. Like, what should be the pattern for passing in a handle? Is it like a copy by value local handle? Is it a pass by reference heap handle? Should we magically turn a local handle into a heap handle when you're passing it? How do you have a pass handle object that carries a type with it? How do you hold on to a handle that carries a type with it? Those are all, how do you pass in a handle and return a copy of the handle?
Those sound like great questions. Should we pull up the README and start looking at them?
So here is the code machine, and here's the README. Yeah, so I just had a few. These are sort of partially converted examples that I then saved off. So this is one. I don't know if this is the best one, but here you're passing in. This used to be a value, and now it's a local handle. And this could be any of several types. So this has to be just a raw handle in some form. But should this be?
Can you help me understand the context here? So emit constant is something that I know we have a parse context. We're in the middle of parsing the program in Wren, or what's going on here?
Yeah, so this one is called, we're in the middle of parsing, and we need to save off a constant. Basically, the reason why you're passing in a value is that Wren, our little interpreter, it sort of smashes compiling and interpreting, or compiling and running into one. And so normally you don't, in a compiler, work with the live runtime objects. But here you are. You're creating a live runtime object. You're saving it off in a constant, and then in the later phase.
I see. So the value exists in some sort of a constant pool, and here you're either ensuring constant. This either puts it in the constant pool or looks it up in the constant pool.
Correct.
And then you're emitting a load instruction for the constant.
And this is always either a string. It's like a string, a number, or a function. I think those are the three types this can ever be. This is a somewhat specialized, and you could imagine refactoring this to be something else. But the crux of this example is, what should this type be? And how should you get in and out of that type? Right? So you've now allocated a string, and you want to pass it in. Maybe the answer to this specific one is that this isn't a value at all. Maybe this should be some sort of compiler type, some rusty num.
I'm sort of wondering if the parser itself should be a traceable object, so that while you're doing the parsing, in case you need to garbage collect, maybe you could trace the parser and find all of the objects that it's sort of temporarily working with.
It's possible. I would suspect that's relatively error prone.
Okay. So you think it'd be better if the parser, when it needed to work with variables, would create a handle scope, allocate local handles in that handle scope, work with them, and then throw away the handle scopes when it didn't need it?
I think it'd be reasonable to have a handle scope for the entire parse time. I guess would that prevent collection the whole time?
No, we can make it possible to collect while there's a handle scope.
Because I do think that we could cordon off to like sections of code. The traceable bit is that we'd have to go look at the compiler enough, but it seems a little awkward to me that you just have to be really careful anytime you add like something that holds onto heap handles that you find a way to trace into it.
Mm-hmm. Yeah, okay. So I think here, in order to use local handle, you need to pass some lifetime, right? Like, do you need to do this to make the compiler happy, or was the compiler happy with this code?
Oh, I don't know. I mean, I could go pull it up, but there's like 1,000 errors or something left in terms of completing. Again, I don't know. We could sort of give a tour of these, and then we could pick which one to solve here.
All right, let's do a tour. That's a good idea.
I think this is more of the same. I think this is another one. This one you hold on to. So this is actually in the VM. This is just a load or store call, pulling things off the stack. These probably actually want to be heap handles.
Mm-hmm.
This one is a typed example, and here's some pseudocode because this doesn't work today. But here you're creating an obj fiber, and this always takes a closure. So this is why typed handles was the title of the episode. I could very clearly see us wanting something like this, where like that it points off into a handle that holds onto that Rust type, and it's like a panic if that ever is not the case. Like it either can be that Rust type or nil, or maybe you have one that can only ever be that Rust type and never nil. Never not.
So here we talked about a pattern where instead of trying to return, a fiber is another managed object, right? Like it's a object that's managed by the heap.
I think it currently is. I do wonder if it needs to be. Again, it was an object in the C version for traceability, I think.
Because I wonder, like we talked about, instead of trying to return these objects, if you pass in a place to put them, like you pass in because if you're going to put them on the stack, like does this eventually go on the stack, or does this go in a field in another object, or where does it end up?
This thing is the actual Rust object, so it hasn't even been wrapped. It hasn't even been passed back into the heap.
I see.
But again, that could be changed.
But that could be a problem, right? Because if it's a Rust object that is traceable, so it contains references into the heap. If it isn't itself reachable from tracing or from a global handle, then if garbage collection happens, those references will not be visible to the tracing algorithm.
And I think this is mostly an artifact of the fact that so I think maybe handle actually is like the code in the value world and the ref counted world that we have today. I think I don't remember why it wasn't this, but it totally could be just as well.
So if you want to return that, then what you need to do is you need to pass in a handle scope.
Because you need to be able to allocate one.
Yeah, because otherwise you need some other lifetime to hang this handle off of. The other pattern is instead of passing in a scope, you can pass in a slot to like an out parameter to write into. But this pattern will work fine.
Let's see. There were a couple others. Returning some type of handle. So this is variable by name.
So I think actually then, to be precise, I think you'd end up with like a lifetime here, and then local handle that same lifetime.
Okay.
That makes sense. You'd say like this local handle belongs to that handle scope.
And what is this thing then? Because this doesn't exist today.
But this could be anything, right? This could be just local handle, and then you don't really care which lifetime it is. It's some anonymous lifetime.
But do you ever pass local handles by value this way? I guess it's not by value. You're not copying them. You're handing it off into here.
You can copy them. They're copyable. We can go look at it, but I believe they're copyable.
Okay.
Should we go look and see?
Sure.
Yeah, they're just copyable. They're just really an index into the scope, so like it doesn't. And they're not tracked like they're like the entry in the scope doesn't go away when all the local handles go away. The entry in the scope goes away when the scope goes away, and that's why you can't really hold on to scopes for a long period of time because they just keep sort of growing and growing, and then you throw them all away at once.
So really, what the local handle is it's this lifetime. That's the real. It's an index with a lifetime.
Correct. It's basically saying that ensures that your index doesn't outlive the table, the vector that it's an index into.
Okay. Okay, that makes sense. Let's see. Example of saving a handle passed into you or copying and returning a new handle.
Those feel like those are more concrete examples of those things above, or is this a different from what's listed above?
I think this is a different one. I don't see one that I made here, but we could go find one. Returning some other example of returning some type of handle. This is look up a variable by name.
Okay.
So this, I suspect. Go ahead, sorry.
I would try to do the same thing here, where I would pass in the scope.
Oh, I see the scope to allocate it into.
And then you can just return. I don't know what option here is, but is this option like local handle of that lifetime?
Yeah, I don't know why it was an option because I think the option was showing whether or not the
lookup could fail, I guess. Right? Yeah, which is fine.
But in our new world, it would just be that.
Well, because we would use nil to mean the lookup failed or whatever.
Yeah, I suspect that's what Wren did too. Because that was a little awkward because there were two different ways. You could have the lookup succeed and have it return null, I guess. Maybe I was trying to differentiate that. I'll have to look at that when I actually do.
You could do either way. Like it's totally fine to return option of local handle. Right? It doesn't matter what semantics you want for Wren.
This is as try return value. So this was on the error object. And here, this presumably again, this is like convert an error into a handle effectively. So this is just, again, you pass in a scope.
Yeah. Passing in a scope is sort of the easy way of doing all these things. If you need to crank down the efficiency, you can do that with some various tricks. But this is the sort of cheapest, normal way of doing things.
It's fine. I think I could get quite a ways that way. Yeah. So and then things like this we need to like clean up. Like, is this just scope dot?
So I try to move all of the object creation functions onto scope, just because that's the easiest thing to do for like the ones that are actually immediates that are stored in line in the pointers, in the tag pointers. And so you should be able to create objects using the scope.
So here, for example, this is another example of sort of cloning one. So we have I don't know exactly what this VM error is. This may need to be represented differently. So this VM error is some enum, and either we have a string because it came from internally. I suspect it's, this is going to change. But when a fiber abort is called, it creates a VM error. I'm just going to restart this. What do you say?
Well, that'll probably be like a heap handle inside of this VM error, and then you'll call scope.from heap to convert into a local handle.
I see. So you do scope.from heap.
Yeah.
Okay.
I think we should try to write some of these. Like, should we put some of these in our example file and try to make them actually?
Yeah. I mean, another approach to this is to, or a related approach, is to take, where's example? Bin, and just clean these up, tighten these down.
Okay. It's easy to write the sort of fantasy code in the README that's like, okay, we think it'll work like this, but it's quite another thing to like have the compiler actually like run it.
Yeah, so other two concrete things, and I think we just need to decide here. But one of which is having a handle that's typed, either for passing or for holding on to.
Mm-hmm.
Which we don't
I think these are two separate operations. So I think we should let's try to get these structures down with untyped handles, and then we'll do another pass over to add the typed handles. I don't know if we'll get it both done in this episode. Or we could do the other way. We could do the typing first. But I feel like we sort of thought about this a little bit. We might want to just make these actually compile.
what you've said here all makes sense. Like I think the piece that was missing in my brain when I was attacking this was just the idea of passing around the scope.
Mm-hmm.
And then I also think adding these, which we're missing a few of, to like make values from scopes. That stuff I all know how to do.
I see. So you sort of see the path there, and so you're more interested in doing the typed handles because we're not sure about the path for that.
Typed handles, I think I see the path there too, but it's a little. There's more fog of war there for me. Yeah. Like, because you want to somehow get from a handle to a typed handle, and I don't even know, can it be the same type with two separate parameters? Like, is this even legal in Rust?
I think so. I mean, we can find out. I'm not a Rust expert. Like, we have approximately the same number of hours writing Rust, you and I. So
I would love to try that. So if we can get to some sort of handle, local or otherwise, local or global, that has a type associated with it.
Okay.
So let's write some fantasy code.
Well, I think the main question is, are we going to try to share, like, are we trying to make local handle itself have a type parameter, or are we going to have a new kind of handle that's like typed handle that has a type parameter?
Well, we have these two orthogonal things, like the lifetime of your handle and the typeness of your handle.
Yeah, it would be nice not to proliferate.
Yeah, it'd be nice if we didn't end up with 4 handle types as a result.
Okay, so let's try to make local handle itself have a type.
I'm trying to see where our.
So I know in Dart there's this type like dynamic, which is like, I don't know, I've lost the type for you. I think in Rust maybe they have a type void or something that's like that.
Any or void or.
Yeah. Oh, this is a crate. Anyway, we can try to find that, but it's unit. It's just parentheses. That's right.
Oh.
Like left paren, right paren is their unit type. So
this is type handle. This is test type handle. Let's see. Typed handle test. Okay. So we want to create a number, store it in a typed handle for number, and
get
it back out.
Okay.
And we also want like a different one that's like create a number, try to store it in the wrong type handle, see it panic or whatever. Get the programming error to do that.
Okay. And then maybe the same thing with string, because numbers are these like tag pointers. They might be different.
We can do string or whatever. That's fine.
Oh, we could also just do both. Okay.
Okay. So
we just start our normal test preamble, make a heap, make a handle scope.
Okay. But
here you want to say like, oops, like local handle string.
Mm-hmm. Yeah.
So this is like take string, for lack of a better term.
Well, it almost feels like you want.
Well, here we just have. This is what it normally looks like, just for the sake of comparison. So like you kind of want this to just be like typed, right? And then and we're just writing this down for the sake of being explicit. Like normally you wouldn't write this down, right? Russ would just know this was the type that you got.
Like, should it be free to go from a typed handle to an untyped handle?
No, I think the Rust way is you'd have to say like into or something.
Okay.
To like erase your type.
Makes it explicit.
I just feel like you always have these intos and as in Rust when you ever do these type conversions.
Okay. So this is just take and take typed.
Well, I think we might eventually get rid of take, but we could just, for for trying it out, we could try to make a new function to make this work.
What would it mean to get rid of?
Oh, just always have take, like, basically to make that work. Right?
Well, even better, you want this.
Yeah, the only challenge there is because this type is actually like &str. So it's a little bit like the two string actually makes it into a string.
I see.
Like if you had
well, that's what the value type used to have, a from string and a from stir for that.
Yeah. I mean, we could try to do that too. That's just slightly more ambitious. But like, I'm sort of hoping like that would work, right?
Yeah. All right.
This is really a string, right?
We're
it's a separate,
eight layers deep. I think I can make this kind of thing work later. It's this local handle string that I want to fight with tonight.
Okay, so let's try to fight with it. So where's local handle? Take me to your local handle.
Okay, this thing. So just add a second parameter with a default. It's like t equals unit.
I don't know. What does Rust think of that?
Let's see. Let's say struct takes 0 generic arguments, 1 generic argument was supplied.
So the only error is in our new test.
It's never used. No, it just had.
We need this phantom.
Oh, I see. The phantom data thing to hold on to the T.
Yeah. And then when we knew it up here.
The warts of a language.
I never know how many like.
Phantom data just feels like one of those things that in Rust 4 they're going to finally remove because
it's very mysterious to me with the phantom data. Like why
that they realized they didn't actually need to do the special dance around the fire every time.
More fish.
Type annotations. We cannot infer the type for parameter t.
Okay, so just make it unit.
Oh, here?
Yeah, more fish. Need more fish.
I'm sorry. That one? Oh my god.
Yeah. I don't know. I think we just keep. It's like a fish. It's like a blowfish. It's a
It's like some emoji off of Twitter. I don't even want to know.
I don't know why this equals. Maybe we should figure out. Should we learn about default? Default.
To avoid our kissing fish.
I mean, the kissing fish. It is beautiful.
Something that is beautiful. Yes.
The top hit on Stack Overflow is why Rust don't use default generic parameter type. Something.
All right, let's try adding our kissing. I'm not sure I can do it, but we're gonna try adding our kissing fish in a few places. This is making me think that we're gonna want to wrap these.
Okay, but let's be real here. These should be T, right? Just. They shouldn't be kissy fish. They should be T.
But why doesn't it infer T?
Well, let's go back to our new.
Should they be T or host object T? T is host object.
I don't know. Well, we got a T. Let's try T. See what happens.
More T's. Stop T's.
Right. I think the issue is because we've already erased the type too much. But yeah, this is fine. So from global handle also. Wait. Global handle needs a T now. More T. Insert more vets and T's. Phantom data.
It's been probably a decade since StarCraft 2.
I will still make the jokes. How do we create these global handles? Where do they get created? Somebody must create one.
Oh, global handles. Oh, I'm
Yeah.
sure that it'll
It'll
start
tell
to
us.
yell at us.
But the point is, it should be global handle T, and then you should give the T to the local handle, right?
You mean that this one should be?
Yeah, that should have a T after the E, but yeah. Right, if you have a global handle,
And then won't this need to be?
yeah, I mean, more generics.
Oh man.
Hey, you asked for this. This is what you want.
Phantom data in the scope.
Oh, I think I spelled it wrong. That's fatten data. That's the wrapper version.
Phantom data. That reminds me of also from a decade ago watching the Phantom ship, whatever Metroid speedrunning.
Oh, the Phantom ship in Super Metroid.
Yeah, Phantoon. Phantoon.
Oh, Phantoon is one of the bosses in Super Metroid.
Phantoon, yeah.
I watched a Super Metroid speedrun the other day. They have gotten so fast.
Really?
Oh, yeah.
I haven't watched them in a long time.
I mean, it's just like time marches on and they discover all these new glitches or whatever to make things amazing.
Can't find fan.
And maybe just import it. What
core marker phantom data or standard marker? We want standard. Well, I don't. Yeah. Impulse needs to be T.
Use SCD marker. Yeah, is that better?
Mm-hmm. That should be it.
No, is that wrong?
Resolve import. Use standard marker.
Yeah.
Oh, you did. You missed your phantom again.
Oh, sorry.
Okay. Cannot find T or T's.
Insert more T's. The T's will continue until morale improves.
We're just cycling through all our greatest hits tonight.
This is how I write code, actually, is I just like talk to myself in nonsense memes. I think you need another T after impl.
What? Oh, I need more
More
T's.
T's.
Okay.
More T's.
Oh my God, we need kissing fish.
More fish. No, a T fish.
A T. Oh God. As long as this is buried.
Well, heap handle, now we need a T on heap handle. It's like infectious, right?
Okay.
And more phantom data. I mean, it's working. This is what we should be doing.
Okay.
It's like a chain reaction. We've like introduced the T into the program, and the compiler is like, why not more T? You're missing T over here.
I do feel like generics are less scary in Rust than they were in C++. I haven't written C++ professionally in a long time, but all right.
Oh, we need to use unit here. This is good. This is where we want, many kinds of brackets. Pick the right brackets in the right order. I think you need one more close angle bracket, at least on the last line. Yeah. Maybe even on the previous lines as well. Yeah, you need more close angle brackets on those lines. One more on the previous line as well.
Why is it not helping me?
It doesn't have bracket matching for angle brackets?
It does not appear to have.
No, that's too many. Look ahead.
Too many. Fewer brackets. Missing generics for struct.
Oh, more T.
Oh my God. Okay.
The function needs one too. Now, do you need one in the return value? Or it just figures it out? I guess if it's not complaining, what? Oh, Fatum. Sorry.
I don't know. Failed to resolve. Fatum.
I fat figured.
Something else you're going to learn to type phantom. All right. T is already taken.
Oh. This is good. Okay, so this is exactly what we want, right? Because we don't want actually conflicting.
Well, is this the right T? This.
Let's make this a different T for now, but we eventually want to match them, right? Because part of the point is when you get the object back out, you should have to get out a matching type. But I think for now, let's make it a different T.
Well, that's actually the whole point of this, right? Is that
but I just want to fight that compiler war separately. Compiler war before it. So,
but just to be clear, that's the whole point of the typed handle thing, is that you can
yes.
then, and that's why I actually wonder if it's a handle or if it's some like wrapper around a handle or something, because you want to hold a handle and a type that then that then you can access through, and it does that type checking. It turns this function call into an object.
Mm-hmm.
But maybe we just smash it into handle like we're doing now, and that'll be sufficient.
I love everything you're saying. I feel like if we try to do this now, we will have a lot of trouble.
Okay.
I think here. Yeah. I don't know if S is the right.
As mutt. Less mutt.
Am I doing it? All right, we have this. Oh, okay.
For heap handle, T.
Right. You need a lot more T's. Like it's good. You just more T's. T's everywhere.
I just enjoy that we have countable numbers of T's.
T, and then we need more kissy fish. Local handle. T. What more T's?
When my kid was younger, we read some book about kissing fish. I'm spoiling the plot of the child's book, but it was the pout pout fish.
The pout pout fish.
The pout pout fish with the pout pout face.
I can let you keep chasing down these errors because you got the actual analyzer. Oh, good. Oh, we need to make our phantom data now. This is good. I was wondering where this was.
What do you do, fan? First of all, you spell it right.
Yeah, but you got to put in the
Something like that?
More fish. More
fish.
And then it's default.
Okay, missing generics. This one's got to have a T, trace handles.
Yeah, sure, why not?
Now, this is where I'm starting to suspect if handle should be generic and there should be some wrapper around handle that does this. But
yeah, I think this is a good signal. Well, this is a signal that something's not quite right, but it could be okay. I feel like we're going to code generate a lot of really redundant code.
Yeah.
But that's okay. I don't think we should back out now. We've come too far.
No, I do. I agree with you. I think we should keep going until we bottom out and we learn whether this works or not.
Or T's. Do you have enough closed things?
And this is actually for any attempt at making this a learning, podcast or whatever. Like this is why you want to do these big things while the system is still small. Yes. Because like trying to integrate this with
it's supposed to already integrated this into Wren VM, right? Then it'd be like, oh boy.
Oh boy. Yeah. Yes. Oh boy is right. Okay, so this is Phantom, in fact.
I'm going to make my own version of Rust. I'm going to fork the whole Rust ecosystem and just to rename Phantom to Fathom.
Well, this one doesn't even have an H.
I'm going to call it Awesome Rust. Or fish. You're missing your fish.
Right, well, I'm going to make this one be Phantom instead of Pathom. I probably typed the pattern wrong. I don't know. Okay.
I don't know where you put the T here. Where you put it here?
Which of the heap handles gets the T?
The self, right? Just for the sake of our sanity's sake. I don't know.
Is this also self? Just, yeah.
I don't know.
Is this self?
I don't know. What type are we even in here?
Well, that is self.
Yeah, this is self. Yes, this is
self. Oh, I'm loving this self.
Self is great. I really wish more languages had self.
What, you capital self, you mean?
Yeah, just like whatever type I'm in, I forget what it is. Just that one.
And is this supposed to be self too?
Yeah. Maybe the return value. Why is it unhappy here? Mismatch types. Oh, maybe the return value is.
We have a
expected.
T and it is not expecting a T.
Oh, local handle.
Right. This is supposed to be T.
It's just supposed to be self. I think it's the.
Yeah.
It's supposed to be T. I agree, but I think the moral way of saying that is just say self. I'm going to get rid of this equals unit thing because I think we haven't learned how to use that properly yet.
The which, I'm sorry?
I got rid of. Remember, we first typed for local handle. We said T equals paren. I just got rid of that because you see in all these now places it's lighting up where we didn't write T correctly.
Okay.
So this should be local handle F64.
Mm-hmm. It should be local handle.
Is null in all caps a type? Or null with initial caps, like capital N-U-L?
Or none?
Like, what is the type of none?
None is an option. It's an enum.
It's an enum. Maybe leave this as unit for now. Oh, you know what? This should be F64, right? I think you should leave null as unit. I don't know quite what the. I think this is not quite correct. Do you want to put a to do here to figure out like what type should null be?
Look it up.
This is a in type systems. This is the difference between top and bottom. So this is actually a thing that Dart does really well, which is in Dart, dynamic is top. I think I get the top and bottom mixed up, but it's things. It could be anything. Hi Frank, good vibes. What is good vibes? Is that what we should be typing?
We may need some good vibes tonight.
You're just helping us out with the good vibes because we could really use them. Anyway, but in Rust they have both null, the type null with a capital N-U-L, and also the type dynamic. Yeah, and so future null means it's a future that doesn't give you back anything, but there's also future dynamic. So future dynamic could give you back anything. There's a difference between anything and nothing.
Oh, this is going to be S again?
T. Right?
Well, but we're creating with T. I see. This is a return with T.
Yeah.
Mixing generics.
Also T.
Mixing generics.
I see. So all the places we were putting local handle, we were just.
It's a handle scope. Okay.
So the T, right?
As we type this, it makes me wonder if we need a.
We can also make just like a type def for it.
Exactly, like a type def on the scope or whatever.
Mm-hmm. Well, with the scope, you want to be able to create different types of handles.
Yeah, no, I agree. The T is specific to these functions here. All right, struct takes one.
This is F64.
Try into.
Well,
but that's this is all the magic here, right? Is that try into for F64 for handle. This is for handle T.
I see. For any T, you can try to turn it into an F64. Yeah. Okay.
Well, and this is again where maybe they need to be separate.
Well, now you could have you could just have an into, right, or a from. Or say from local handle F64. I know this is going to succeed, or else I'm going to panic.
Correct.
Should we write it to do for that? Like, I don't think we should type that right now, but I think that's the victory lap of doing this.
And again, it's not clear to me whether because the typed handles are really for long-term storage or for argument passing. Because most of the time you work with untyped handles.
In Wren. Yeah, that's true. But that doesn't mean you shouldn't have this conversion, because the conversion is legit, right? If you have a local handle to an F64, you should just be able to, without an error, get back F64. You may not use it, but conceptually it makes sense.
Okay. Mismatch types. For global handle T. What?
Oh, we need the type erasing thing, right? You're pushing. We have a very the globals array is of unknown type, so you can just change that T to a paren.
Works.
Oh, look at that local handle drop object. So this would be global handle drop object. You can also just erase the type if you want. Oh, I see, because into needs to know.
Well, is there a way to have an untyped, like you want to be able to type this?
We just haven't written that from function yet. Like for each of the handles, we can write from T to parens, and we can't necessarily go the other way easily.
Okay. What do we got here? I see.
This is
just
from unit to unit. Yeah.
Oh, I see. You could imagine having a typed one, but like.
But Wren doesn't have that, right? More fish.
More fish. What? I think it's just here, right?
Oh, you're right. You're right. I never know where to put the fish.
Okay. Trait bound.
Right. We need the thing, because now these are local handles to strings, and we need to write the converter to convert, to erase the type, because you're putting them in the map.
Oh, I see. Okay, yeah. See if there are any other easy ones here before we type annotations needed. Cannot satisfy default.
This needs also like a.
Yeah. Again, I just wonder if this is going to end up needing to be a thing on top. But I don't know. We'll get this. We'll see.
I'm always a big fan of doing it the verbose way and then adding the sugar in the second phase.
No, this is like a separate design question. If all handles should just be untyped, and then you have to wrap the handle in a thing
to hold the type,
like a typed handle, right? Because then you could imagine having your like struct typed handle, which like has the handle type T right. Handle type, or whatever handle type, and then also the like value type. And you have your like handle type, and then you have your phantom.
I see. But the alternative to that is basically you could have just like type dynamic deep handle equals.
Sure. Yeah, and I think you in the way that we're currently pursuing, you clearly do that, right? to get rid of some of the fish. But where did I go? Where did I lose here?
I think we were an example, maybe.
I hit the like back button or forward button on my mouse, and I'm totally lost now.
We were an example on line 20.
Anyways, with this, again, all this does is it gives the Rust type system something to glom onto, so you like don't lose the type when you're in Rust land, which is the only time you care about hold on to the type. And it also gives you quick in and out access into a handle without having to, every time you want to get or set, have to say, oh no, I'm really getting or setting this thing, this type.
Yeah, I agree with you.
But we should finish this exploration and see.
Yeah. My intuition is that this dynamic type handle thing is the way to go. Like maybe you give the untyped one the shorter name, but
Yeah. I see where it's like type T handle, T, and then otherwise it's heap handle. That is okay. Yeah, I could imagine seeing that work. All right, here we go. Missing generics for this. Now I'm add. So like here, because you don't know.
You're getting these out of this, yeah.
And you could actually this you could give it a type.
Well, it's interesting. It's sort of like whose job is it to do the type check, the caller or the callee? Here you can find out.
Or it would be ignored. Like the callee is going to ignore this type.
Well, not necessarily, right? Like here you have try into. If the caller was responsible for doing the type check, then the callee could do an unconditional conversion to a float.
Yeah, it's true.
And I think in your example, like this argument would be a place where you would have the caller guarantee the type.
Yeah.
For example. Yeah.
Yeah, and then you could centralize this conversion handling, right, and this error checking.
Because you need to do it for the dispatch anyway.
Yeah, which that's like a difference of implementation from Wren, and so you'd want to do that separately because you would break a bunch of unit tests because they handle this slightly differently, and thus the error message are different.
But it's giving you the at least the vocabulary to be able to say those kinds of things and make those choices.
It is, which is an interesting argument for this as a method, right? That you just always drag around the types when you can. Okay, same thing. This may be winning, or this may be growing on. We'll see. Types.
It's actually a stack. So if you go back to your VM, you can give that handle a type in your VM because it's always a stack.
Yeah, this is exactly what I wanted to be able to write. Like exactly, because this is a great example of this. Is that
if your thing is not a stack there, you're going to have a bad day.
You're going to have a really bad time, and you really don't want to type it every single time. But this is a fantastic example of exactly why you want this. I have no idea. Okay, so now we have to do these ones, right? The intos. We have to drop the types.
Right. So I think maybe we should just add an erase method on each of our handle types. It just drops the type.
On each of our handle types?
Yeah, so you go back to local handle as an example.
Like this. Local handle, yeah.
Like, what if you added a method here called dyn, D-N-Y? Oh,
I'm sorry?
That's probably a reserved word. Let's try adding a method that just erases the type.
Okay.
We can pick a name for it, whatever you want.
It's just it returns back. That's right. I'm thinking Dart here. Dyn is in fact a reserved word.
Okay. Erase type.
Okay, sure.
And then
and then you want a local handle. Oh, this needs an A, doesn't it?
Mm-hmm. Oh, you just need a self, really.
It's not quite self, though, is it? Oh, I see. Yeah.
Oh, sure. It'll infer the lifetime because it matches self.
Well, and then I don't remember what the parameters are here.
You're going to make a new phantom data, but aside from that, it's fine. Yeah.
Self.scope. Index. And this is right?
With more fish, but yeah.
Where? Okay. More fish. Okay. Comparison operators cannot be chained.
More fish.
What if we just remove this? Is it going to be sad about the missing types?
Okay, but we do the same thing for heap handle and for global handle. And then you can just write erase type in all the right places in your program.
Yeah, that's the like super manual way. We're going to have to do something.
Yeah, I'm sure there's a smarter way of doing this with like from traits or something. As just a way to get started.
Okay. Inner, index, and phantom. I haven't learned to like. Oh my goodness, my mouse has learned the command though.
This is going to have to be a like this. We're going to consume this thing.
It's going to be at the what?
Oh, it's a yeah. Because the drop for global handle, like global handle, is not clonable.
Mm-hmm.
That's fine.
Cannot move out of global handle T, which implements drop trait.
Right.
Should we instead be modifying this?
Should we instead be modifying? We're going to have to change the types. Huh. I don't know how to do this.
Searching the Stack Overflow.
Yeah, I want to like. I mean, you can do it with an inner object pretty easily. Like if we put the inner and the index into some other struct, and that was the thing that had the drop trait. Basically, doing the typed handle thing that you were talking about for global handle. Do you want to do that to move past this, or do you want to?
I mean, yeah, I mean, I understand what you're talking about. I'm just because you don't see a path past. You can't move out of something that has a drop trait without.
Yeah, like we want to transfer. Like we want to take responsibility for what that drop trait is doing, and move it on to the thing that we're returning.
Is that not possible?
I don't know any way of doing that except to move it onto a sub-object. Like there's, you can say forget, like, they're like unsafe ways of doing it, but this is the safe way of doing it.
Mm-hmm. And we'd also be losing the T in case that mattered for the drop, which I don't know.
Right, which it doesn't happen to matter. We can just, I mean, this is easy to do, right? We'll handle here. Just move this stuff over here. Inner, but oops.
Oh, I see this thing.
More errors. Inner, like we should call it something besides inner. Global handle. In reference. Reference. Root.
Okay.
So we are root. Your name is Root. I did it. What's that root?
Look, Mom. Root does not implement debug.
Well, it does now. I would say root is a self.root. And then we would do this drop trait on root.
Okay. Missing structure fields, root.
Right.
This stuff needs to go into root now.
Yeah.
No. Okay.
Okay. So now we need heap handle. Do the erase for heap handle.
Well, this one we just have. Yeah. Okay. We haven't used any of them.
That's fine. But
erase. Packet pickup. B. Default hash. Yep. Those are still on Sesame Street, by the way.
Are they the Martians? Is that what they are?
Yep. In case anybody's watching Sesame Street, PBS is amazing these days. By the way,
I thought Sesame Street was transferred over to HBO or somebody.
Oh, yeah, Sesame Street, yeah, whatever. But the PBS itself, and particularly the PBS digital, there's all sorts of adult content, and I don't mean it that way. There's all sorts of content for grown-ups. It's great. I may have taken us off track.
Okay, so now we just need to put erase before the intos, I believe. Or maybe either way. I'm not sure. Yeah.
Gorgeous. Couldn't have written better, longer code.
I don't know how like smart into is, like whether into can find multiple froms to get you from A to B, or whether you have to.
Question mark does like recursive into. I mean, this is a little lame.
You just erase this.
What's this? Cannot move out of self pointer.
What is self pointer?
I think you want this to be a cell new.
What is tagged?
Or clone.
I think I just want. Can I clone a cell?
Yeah. Oh.
Okay. That's fine.
Well, is this safe?
Why wouldn't it be?
Well, the heap handle, if this is immediate, is the actual storage of this tag pointer.
I think it's fine.
Okay. Why is this not used? I don't know. All right. Now we can get to it, right? String typed. What?
But take is just take string typed. Like there's no difference anymore. Like just erase the just say take, and you need two string. But yeah, like we did it everywhere. You need to unwrap because it's a result.
We did it. Okay.
I mean, we're also at the 59th minute. I think we did typed handles. We didn't do the thing where you can now get the value out without an error, but that's okay. We can like.
Yeah, I can see a path to that. All right.
I mean, I'm amazed actually that we got the compiler to accept the nonsense, but it worked. We had to work on the ergonomics of it.
Yeah. Yeah, I mean, we've definitely, certainly with the type erasing, like this is, we made our problem worse in terms of getting to Wren. Like
we increased the verbosity.
Well, we solved one problem of we made it now possible to have typed handles, which that's great. Like, and we should go look at actually dot stack. Well, I hid the. We add back to this just real quick. I know it's time to go, but dot stack. Where were we? This thing.
Mm-hmm. Right.
Yeah,
that we can, because
right,
we now
like
know
this.
it knows that stack handle is, yeah, and we don't need to unwrap anymore, right? Because we know that can always succeed. Like we could go write that function and make that work.
Yeah, maybe this is.
I don't think we should try to do it right now. Like, but we're quite close to it.
But that's the victory lap. Once we do that, then that was the reason why we did all this.
Because it knows, like if you look on line 65, like it knows this is a local handle to a stack.
Yeah. Anyways, once we do that, then this becomes better, because then you can just do then you have a like what is it?
Mm-hmm.
Yeah, this just ends up being stack. You just you do stat dot asmut dot values dot push.
Mm-hmm.
Yeah. Anyways, another potential reason to wrap this in another separate function is that, like, you may want to put this push somewhere. I don't know. We'll see. We can look at it more later. Anyways, this was great as always.
Yeah, it's fun to get back to the GC.
Yeah, I'm excited to feel unblocked and to go a little further. This is one of those projects like Wren where I just need to do a whole bunch of typing behind the scenes in order to actually keep us moving forward. But so December is going to be a little weird, I think, because it's holiday seasons. We're going to try and stick to Thursdays, I think. But we may need to move to some Tuesdays this December. We'll come with dates.
We'll try to keep up the one episode a week cadence. It just may flop between Tuesdays and Thursdays.
Exactly. So,
but you can always find it on YouTube if it's Thursday and you wish to see us live and we record it on Tuesday, it'll be on YouTube. It's not as fun. You can't come in the chat, but Yeah.
Anyways, glad you joined us, Frank. And we'll see you all next week.
Yeah. See you next week.
Nice to see you, Adam.